triangles. Now, this one we are looking at some applications of trigonometry in 2 dimensions, and it's all about problem solving. The thing that we're going to start with is we are actually going to start with some angles of depression and elevation. Now, if you are doing that 5.3 course, this should not be new information to you, just a rehash or a revision of what you have done previously for some of this. Now, some things to think about: our angle of elevation is from the horizontal up, and the angle of depression is from the horizontal down. So that's angles of elevation and depression. If we are going to solve some slightly more complex problems in terms of 2-dimensional applications of trigonometry, some things that you need to think about: you need to visualize or draw a diagram. And that diagram really should involve a right-angled triangle, with all the different relevant information. So that's the first thing that we want to do. Then we want to use trig ratios to find the unknown. So whatever it is that we're trying to find, let's use our trig ratios, or the appropriate trig ratios, in order to do that. Check the reasonableness, pronounce that correctly, reasonableness of your answer. I'm probably not spelling that correctly, but what you're looking for is your answer feasible? So for example, if you have an angle and your answer comes out to be over 180 degrees, then it is definitely not going to be your answer, because triangles add up to 180 degrees. And then you should answer the question in words. So they're the 4 things that you should be doing to answer problems in trigonometry. Let's dive into a couple of examples. Here's our first problem. We have a helicopter hovering at an altitude of 250 meters. That is our vertical. The angle of elevation from the helipad to the helicopter is 35 degrees. So this is that little bit in there. We want to find the horizontal distance of the helicopter from the pad to the nearest centimeter. So we want to go that way. So we start, we've got our drawing already. We don't need to draw this up. We already have our drawing there. So we choose the relevant trig ratio. We're not using a hypotenuse, so the trig ratio we want to use for this is going to be 10. So we want 10 theta equals opposite over adjacent. And you can even mark that on the diagram. Opposite adjacent. Now we can fill in what we know. So 35 degrees, we know the opposite side is 250, and let's chuck in an x for our unknown. What we want to do is we want to use the trick we learnt a couple of videos ago where we switch around the tan 35 and the x. And we can step it all out if you'd like to, but we're going to save ourselves a little bit of time. So we're going to get to there, and then we're going to type this into our calculator. So here's our calculator. It's on. We want to go 250 over tan 35, close off our bracket, equals, and we get 357. But we want that to the nearest centimetre. So what we're going to do is we're going to write down a couple of decimal places. So that's 357.037. And that's in metres. Now we're going to have to go up a little bit here because I'm running out of room. So this in centimetres, is going to be multiplied by 100 because that's what you do to metres to get centimetres. So it's actually going to equal 357.037 times 100. Let's do that. So we're just going to times our answer here by 100. And this is what we get. 35,703.7. And if we want to round that up to the nearest centimetre, it'll end in 04. So that's that problem taken care of. And if we follow the final step from before, write in a sentence. So the helicopter 704 centimetres from the helipad. Just squeeze that in. So that's how we go through the problem. Make sure you're labeling diagrams appropriately so we can see what's going on. Let's look at the second example here. We have two vertical buildings positioned 57 metres apart, and they are 158 metres and 237 metres tall respectively. Find the angle of elevation from the top of the shorter building to the top of the taller building, correct to the nearest minute. So let's zoom in a little bit. Here is our diagram, and we want to know theta. We want to know this angle in here. We have this little bit here that is our right angle triangle. So let's drag that off to the side, or actually let's put it down the bottom. We have 57 metres right there. We have theta in here. We might need to make that a little bit clearer. Make that a bit better. Okay, so there's theta. We know the side length over here is going to be 237 meters. 237 meters minus 158 meters, which equals, let's work that one out. Get rid of our old answer. 237 minus 158, 79. 79. And we want to know that theta. So again, we're going to use tan because we don't have a hypotenuse. So I'm going to start up here with tan theta equals O over A, so that it's working within my ratios. Tan theta equals the opposite side, which is our 79, over 57, which is our adjacent side. And then we can figure this all out. So it's going to be theta equals tan of 79 over 57. Let's see what this says. And we're going to answer this to the nearest minute. So let's get rid of that answer. And we're going to have tan 79 over 57. Close the bracket, but let's close the bracket properly. Hit the equals. That gives us that answer. Hit degrees, minutes, seconds. Now that can't be correct, can it? Now if you're watching, you should be able to tell me exactly what I've done wrong. I've actually forgotten to use the inverse. So let's go back in and fill in the inverse. So we still need that -1. So let's go back to the calculator now and fix that up. And you don't need to clear this. You can just go use your arrow keys until you're back to where you need to be. Alright, and I'm going to go second function or shift. Tan gets me the correct bit there. That's starting to look a little bit more like it. Degrees, minutes, seconds. And I have 54 degrees 11 minutes because 19 is less than half. So 54 degrees 11 minutes. And that's the answer there. So let it up in words. The angle of elevation is 54 degrees 11 minutes between the buildings. That works. Okay. That's all there is to it. Hopefully this video has been informative and helpful, and I'll see you in the next one.